morning, this is Mr. Pruitt, and today we're going to be talking about simple and series circuits. Those are basically just uh, circuits that have one path with one or more resistors on them. Alright, so we need to talk about what's required to make a circuit, and really, in these very simple forms, really all a circuit needs is a source of voltage like a battery or a wall socket. It needs a path for the charge to flow through. Usually that's some thin wires or something like that. And then some type of resistor to do work. On the right side of the slide, you'll see symbols that are commonly used in circuit diagrams to show different things, like the battery, which would be your voltage source, bulbs or resistors. You could use either one of those two symbols interchangeably for different bulbs and resistors in there. Switches, which basically are used to turn off or on the flow of the current. The most basic circuit is what we call a simple circuit, and really it's just a battery, some wire, and a lamp or a resistor. You remember that you need to remember that the battery is the voltage source, and it provides what we call a potential difference. We talked about this yesterday. Remember that the positive end of the battery is considered to have high potential, and the negative end is considered to have low potential. There's wires for the charge to flow through. They give it the path. They're the riverbed. And then there's some type of resistor, in this case a lamp. If you look at the pictures on the right, you can see the basic configuration of this simple circuit, and then you can also see what a circuit diagram for it would look like. You can see the battery, the symbol for the battery. Each of the straight lines represents a wire, and the circle with the crossed X in it represents that light bulb. A series circuit is basically just a simple circuit with more than one resistor in it. And basically, the easiest way to think about it is that it's just multiple resistors or multiple lights that are all on the same path. In the picture to the right, you can see that you have a battery and a switch and two lamps. When the switch is in the on position, the lamps turn on, and when the switch is in the off position, current can't flow, so the lamps don't come on. This is much like the kind of light switch that you have in your house. When they draw out the diagram on the bottom, you can see the battery. You can see where the switch is located in the circuit, and then you can see both of the resistors. Now, when we're working with simple and series circuits, there's a couple of really basic rules for you to follow. The first one just says that the current in a simple or series circuit is the same through every resistor, and that should make sense because if you think about it, the amount of current that you have going into a resistor, you have to get the same amount of current coming out of it. Otherwise, you would have a violation of the law of conservation of charge, which said that the amount of charge that you have before and the amount of charge that you have after is the same. Alright, so current has to be the same on each side of each resistor. Second rule says that if the resistors all have the same amount of resistance, so if all of them are the same type of light bulb, or they're all 10 ohm resistors, then the voltage drop is going to be the same across each of the resistors. And if we're looking at lamps, then all of those lamps would have the same brightness. On the other hand, if the resistors had different amounts of resistance, let's say that they have 5, 10, if you had a 5, a 10, and a 15 ohm resistor, or 3 different bulbs, then they have different voltage drops. And since they have different voltage drops, they're also going to have different levels of brightness. And then the last thing, and this is probably the most important thing for this, is that since they may all of these voltage drops that you have across these different resistors, they have to when you finish up with them, they have to equal the original voltage of the battery. Alright, so that's it for today. There's a lab for you to do. Please check with the substitute and pick up the lab and get started on it. It's a PhET lab. It should be fairly easy. You're just going to be making circuits within the PhET. Enjoy yourself. Make sure you turn it in because it is a grade. Thank you. Bye.